Hi guys, this is day 2. Yesterday we covered about track. Today we are looking under the hood. If an interviewer asks you how a system actually understands human language and search millions of files instantly, it is the exact architecture you need to explain. Here you can see embeddings. So what are actually embeddings? First we have First we have to deal with the fact that computers don't understand English. They only understand math. So we use an embedding model. Think of it like a massive GPS map of meaning instead of locations. It takes a word and assigns them coordinate on a giant graph. In a space, things which with similar meaning are grouped together, like a dog and our puppy we like next door, and a dog and some country name are completely different. Cosine similarity. When a user asks a question, how do we find the answer on map? We can use something called as cosine similarity. Instead of measuring the straight line distance between the question and the document, we measure the angle between them. Imagine pointing two telescopes. If they are pointing in the exact same direction, they are a match. This is crucial because it ignores size. For example, if you have a 50,000 page worth of book and you make a 5 word summary of it, if you measure the Euclidean distance, so there will be a huge difference between those two coordinates. But in reality, if you measure the angle, that is the cosine similarity, so a 5 word summary of a book will be perfectly mapped to the entire 50,000 book. But here is the engineering bottleneck. If you have a data set or a database with 10 million documents, checking the angles of the user's question against every single document one by one is often linear scan. In production environment where a user expects an instant answer, this is way too slow. So what we can do to fix this? So production vector database don't look for the exact match. They look for a approximate match using HNSW graph. Think of it like a roadmap. Instead of knocking on every single door in the country to find an address, the algorithm takes a high speed highway, layers to zoom straight to the correct city, then drops down to the local street layer to find the closest house. It turns a massive search bottleneck into a millisecond retrieval. We'll proceed further on day 3. Hierarchical navigation small world HNSW algorithm. So you can imagine it like this. This algorithm is built like a map. There are 3 layers to a map. The topmost layer or the second layer we can call it, it comprises for an example of airports, and the first layer or the middle layer it comprises of all the roads and the networks, and the third layer comprises of the actual homes. So if you want to locate a particular home, so you can check where what is the nearest airport from the second layer. So from your 10 million records, all the 9 million records are eliminated if you want to find a home. And further, if you know the street address, further approx 90,000 or 9 lakh records according to your calculations will be eliminated. So this is how the HNSW algorithm works. It maps your entire data into a basically layer-wise 3D maps. Instead of comparing your one vector across the 10 million points, you now need to compare it to only a small chunk of points.